Hello everyone, welcome you all in C++ templates part 1. In this video we are going to discuss what is template and why we use templates. So let's start. It is very analogous to when we said classes are the templates to create objects. Similarly, templates are itself are the templates for classes. I know this seems weird to you guys, so let me explain with the help of an example. So in this program we are defining a function whose name is calculate minimum and its return type is integer. Here it takes two parameters of type integer and it will return minimum of those two numbers which we passed to this function, right? Then here this is a logical operator, so it will evaluates to either to false or true, right? So this is an expression a is less than b. If this expression evaluates to true, then it will return a, and if this expression evaluates to false, then it will return b. Similarly, next is an overloaded function. It takes two numbers of floating type numbers and it will return the minimum of those two floating type numbers. And third is it calculate minimum. It takes two characters as parameters and return minimum of those two characters. So if we analyze these three functions, then we can say these three functions are identical to each other and only differs in the aspect of these you can say data types, right? So in the main function we are declaring two variables x and y of integer type. Here we input two numbers, then here we are calling calculate minimum function and we passed two integer type numbers which are stored in variables x and y because x and y are integer variables. So control will shift from this point to this function. Here let us suppose we enter 2 and 3. 2 is stored in variable x and 3 is stored in variable y. So here a and b are our parameters, so 2 will be copied to this variable a and 3 will be copied to this variable b. Here this is a ternary operator, so first of all this expression will be evaluated. Is 2 is less than 3? Is this is true? No. So this expression will evaluate to false and b will be returned. So if this is less than b, then is 2 is less than 3? Yes, this is true, so a will be returned, right? So 2 will be returned and it will get printed here. So output contains minimum of integer values is equals to 2. Here we are declaring two floating point variables, right? So here we input two floating point numbers which will be stored in variables p and q which are of type float. So here we are calling calculate minimum function and we passed two floating point numbers which are stored in variables p and q which are further of type float. So here control will shift to this function which takes two numbers of type float. So here again this expression will be evaluated. Suppose we have entered 2.1 and 3.1. So 2.1 is stored in variable p and 3.1 is stored in variable q. So here 2.1 is copied to parameter a and 3.1 is copied to parameter b. Now this condition will be evaluated. Is 2.1 is less than 3.1? Yes, this condition is true, so this A will be returned back. So here minimum of floating values is equals to 2.1 is printed on the screen. Now here we are declaring two variables of type char. Here we input two characters which will be stored in C1 and C2. Here we are calling calculate min function, and we are passing two variables, or you can say two characters, right? So control will shift to this point, to this, and here if suppose we store characters A and C, then A will be copied to this and variable B will store value C, right? So here it will evaluate this expression based on their ASCII codes. So ASCII code of A is less than C, so A will be returned, and here minimum of C1 and C2 is equals to A will be printed on the screen. So let us run this code in VS Code. Here this is our calculate min function which takes two integer numbers, and here this is calculate min function which takes two floating point numbers and return a float value. And third, it is a calculate min function which will calculate minimum of two characters based on their ASCII codes. And in our main function we are declaring variables x and y, then whatever written in the double quotes, that is string, it will as it is print on our output screen. So enter two integer values will be printed on our output screen. So then we will enter two integer numbers. Then here this we have discussed that control will shift from this point to calculate min function which takes two integer type values. So again enter two floating values will be printed. Then we have declared two variables of type float. Then we input two float values. Then again calculate min function will be called for P and Q variables which are of type float. Then again for C1 and C2 same procedure will be repeated. So let us run this code. Here there is an error, and sorry, actually I have select the code and then run. So again run this code. Okay, so actually VS Code gives an error if we select a part of code and then run that program, because VS Code try to run that part of code which we have selected, so that is why I get an error. So here let us suppose we enter 2 and 3. So minimum of integer values is equals to 2, and then next cout statement that we have written string is printed. Enter two floating point number, let us print 2.1 and 3.1. Okay, so minimum of floating values is 2.1 is printed on the screen. Now enter two characters, so let us suppose A and C. So minimum of C1 and C2 is equals to A. So this is our output. Actually there must be new line character, right? You can take screenshot of this program, or you can type yourself and run this program. Okay, so let's save and go back to our presentation. So next example, suppose we want to have a vector for each of the three data types, int, float and char. Then obviously we will write the same code again and again for different data types, and this violates try principle because of repetition of same code. And this we can understand with the help of this example. Here we are defining a class vector. Class is a keyword which informs the compiler that we are going to define a class. So here is the class name, that is vector. Here in this vector we are going to work with an integer array, and this is variable will store the size of the array, that is of type int, and then we have another functions, right? So if I want to work with an character array, then I have to define one more class, and the only difference is this data type. I want to work with an character array. And if I want to work with an floating point type numbers, then I have to declare another class, and the only change that I have to make to that class is this float, right? And then what if I want to work with an array of double type numbers, then I have to define another class. So you can say we are repeating same code again and again. So let's go back to this example. So now we are familiar with the concept of function overloading, in which we use the same name for different implementations of the functions. The overloaded functions are distinguished by means of different parameter list, either on the basis of number of parameters, or you can say or type of parameters. So in function overloading, it may be possible that implementation of different functions are identical except for type of data they operate upon. The problem with function overloading is that program where we not only have to define a separate function for each data type, but also if any new type is added later on the new functions, we have to return for each one, right? So to understand the need of templates, we have discussed this program. So in the theory part, you can write, we observe in the above program the implementation of calculate min function is same and differs only in their data type. If you want to calculate the minimum of some other type such as double, then you need to copy the code and paste it. Just change the data type. So defining multiple identical functions which differ only in terms of data type increases the size of the code, and also there is maintenance problem too in the program. If there is some type of logical errors in the implementation of the algorithm used by the function, it is more likely that the same logical error exists in every version of the overloaded function, and we need to modify all the definitions. So this problem can be resolved if there is a way to write such a function only once, which could work for different data types, and this can be achieved by using concept of function templates in C++. If we use function template in the above program, the calculate min function would be implemented only once. That can work for many different data types. Now, so a better solution to the above problem is to make a generic function that can work with all C++ data types. But how? Answer is with the help of templates. So answer of our first question, That is, what is template? These templates allow us to write a single function or a class for a group of similar functions or classes in a generic manner. What is meant by generic? We will discuss after some time. The template declared for function is called function template, and those declared for classes is called class templates. Once the code is written for a template, it can support multiple data types. Now our next question is, why templates? So our fourth slide. Now next question is, why templates? So first reason is try principle. As we have seen, we are repeating the same code again and again, which violates the try principle. And next reason is generic programming. It is called generic because it is sufficient to declare a template once. It becomes general and it works all along for all the data type. Once the code is written for a template, it can support multiple data types, and it behaves as we have defined multiple functions for each data types. Sometimes templates are also called parameterized class, and reason of this we will discuss in our next videos. So there are two types of templates in C++. First is function template and second is class templates. So thank you for watching this video.